Materialism was the view of many scientists at the turn of the 20th century. This simplistic view that all that existed was matter and energy, and the rearrangements of it, is the extreme view of realism. Realism is a general belief accepted by many today, that a physical reality exists independent of observation, and roughly 100 years ago, most held to one of these two views, rejecting the opposing view, idealism, the view that reality is a mental construct and doesn't exist independent of observation. For many back then, their understanding of physics seemed to favor this side of the spectrum, firmly believing it buried idealism. However, this realistic worldview was shaken with the advent of quantum mechanics. The realization of how the quantum world behaved began to eat away at the materialist and realist beliefs. Matter was thought to be tiny particles that existed independent of our observation. However, the equations of quantum mechanics and the results of the double-slit experiment changed that. To understand what this experiment showed, a simple explanation is given. Subatomic particles were thought to exist like tiny bits of matter, not like continuous waves of energy. However, sending electrons through a double slit showed they acted like waves of energy instead of tiny bits of matter. Even sending one electron through at a time, the same results happened. However, when one set up a measuring device at one slit, the results changed, and the electrons acted as one would expect, as tiny bits and not spread out waves.
When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched.
The conclusion was drawn that the very act of observing caused a wave function to collapse and create the existence of matter, either in the state of particles or as a wave. According to the Schrödinger equation, independent of observation, particles exist in a state of a wave function, which is a series of potentialities rather than actual objects. The very act of observing caused this wave of potentialities to collapse to a state of matter. The results inferred was that matter didn't exist independent of observation or measurement, flipping materialism up on its head. To better explain this, in the quantum enigma, Rosenblum and Kuttner explain with a simple scenario, representing what is actually happening. If you were to take an electron and isolate it in a superposition of two boxes, and open one box, the electron will collapse into either one or the other box. So if you don't see it in one, it will definitely exist in the other. However, if you were to take another pair of boxes and open both simultaneously, the electron would come out of both as a spread out wave. It would display the wave of potentialities as an actual spread out wave. The key to understanding what is happening is that matter doesn't exist as a wave of energy prior to observation, but as a wave of potentialities prior to observation. The waviness in a region is the probability of finding the object in a particular place. We must be careful. The waviness is not the probability of the object being in a particular place. There is a crucial difference here. The object was not there before you found it there. These were the conclusions drawn from the Schrödinger equation and the experimental results at the time. It was only reconfirmed in the 1960s by Klaus Janssen. At that time, though, not everyone liked the conclusion that was playing out. Some, like Einstein and Schrödinger, were deeply troubled by the results of quantum mechanics. So in 1935, Einstein and two of his colleagues proposed a thought experiment to debunk quantum mechanics. They proposed that if you placed two particles in a joint superposition and then separated them by a great distance, an observation of one would instantly affect the other, which Einstein called a spooky action at a distance. The point was the observation of one couldn't affect the other instantly, because information couldn't travel faster than the speed of light. If it did, then relativity would be violated, which didn't seem possible at the time. So instead, there must be some physical, undiscovered, local, hidden variable that was actually affecting them instead of our observation, that matter acted independent of observation and only appeared to be observer-dependent from our perspective. However, in the 1960s, John Bell began to explore this thought experiment and propose an inequality. If this inequality was shown to be false, then the local hidden variable theories would be debunked, and matter would be dependent on observation. This was put to experimental test in 1982 by the physicist Alan Aspect, and the results confirmed Bell's prediction. Bell's inequality was violated. Einstein's spooky action at a distance was real. This confirmed what quantum mechanics was telling us. Prior to measurement, objects have no defined properties or location. The act of a conscious observer creates the existence of the physical objects and the properties they entail, instantly.
Who deserves to trust their intuition more than Einstein? And Einstein's intuition told him, like everybody's intuition tells them, that things are really there when you're not looking at them. Well, he was wrong, right? That intuition is incorrect.
But it doesn't end there, because many propose the existence of non-local hidden variables in Leggett's inequality. However, in 2007, they were also falsified, this time by Anton Zellinger and his team. The results sent shockwaves, and physics world went so far as to say this means quantum physics says goodbye to reality.
So recent experiments led by a group at the University of Vienna, Austria, provide the most compelling evidence yet that there is no objective reality beyond what we observe. So it's really the observation that creates the reality. And what they found is that Leggett's inequality is violated as well as Bell's. Even if you allow for instantaneous influences, quantum measurements do not fit with the idea of an objective reality. So as they say in the magazine, rather than passively observing it, we in fact create reality.
A reality independent of observation doesn't exist. But it doesn't stop here. Prior to this in 1999, the delayed choice quantum eraser experiment was performed. If I'm going to simplify and explain this complex experiment, we need to do so with a hypothetical scenario of modifying the original double slit experiment. Instead of placing the detector at the slit, it is placed past where the particles land. But just before the particles hit the film, it is pulled away and the camera captures the results after they went through the double slit. If they observe a wave, then particles went through the double slit as a wave, and just adding a measuring device doesn't cause them to collapse to particles. But if they collapse to a state of particles at the moment of detection, then even though they went through the slit unobserved and should produce a wave pattern, the very act of observing instantly transforms them into particles. But not only that, a back history is loaded up so that particles went through the double slit instead of a wave. Well, to the dismay of materialists, the results would display particles. Observation creates the existence of particles and loads up a back history so they went through the double slit as particles. Thus it follows particles do not exist unless there is an observer. But the problems don't end there for realists. Many try to explain this away and hold to naive realism, which holds to the belief that a reality exists independent of observation, just that our perceptions are just a representation of something that is actually there, but not a perfect representation. However, this view was also falsified in 2011, this time by confirming the Cauchy-Spector theorem. The outcome of observed reality depends on the measurements at the time and cannot be predicted prior to that, which would be essential for naive realism.
The Cauchy-Spector theorem talks about properties of one system only. So we know that we cannot assume, to put it precisely, we know that it is wrong to assume that the features of a system which we observe in the measurement exist prior to the measurement. Not always, I mean in certain cases. So in a sense, what we perceive as reality now depends on our earlier decision what to measure, which is a very, very deep message about the nature of reality and about our role in the universe. We are not just passive observers.
Then there was also the experiment in 2012, the non-local delayed choice quantum eraser experiment, and the results were quite astonishing. It concluded, no naive realistic picture is compatible with our results, because whether a quantum could be seen as showing particle or wave-like behavior would depend on a causally disconnected choice. It is therefore suggested to abandon such pictures altogether. Thus the conclusion is inescapable. This is why Eugene Wigner could safely say years ago that materialism is not compatible with quantum mechanics. And now with these recent experiments, we can also roll out versions of local realism and naive realism. Not only is materialism incompatible with quantum mechanics, but so is realism. As Zellinger said, we have to give up the idea of realism to a far greater extent than most physicists believe today. Now, if one wishes to just dismiss all of this, I can simply refer you to the Quantum Randy Challenge, where you can win a Nobel Prize and prove naive realism or local realism is true, and not observation dependent. Until then, to just dismiss all this science pointing in the opposite direction is nothing more than a faith-based opinion. Now, many have tried to get around this by trying to separate the quantum world from the macro world, but that was also falsified in 2010 by violations of the Leggett-Garg inequality. And in 2011, Bruckner and Koffler showed that macro-realism does emerge from quantum physics, so you cannot separate the two. This should be obvious since double-slit experiments have been performed successfully with larger things like atoms or molecules, and experiments are being devised on how to do this with mid-sized proteins and viruses, and no one doubts the results will be different. Other elements of quantum weirdness have been seen in macro objects as well, such as quantum entanglement between two aluminum chips, big enough to be seen by the naked eye, and putting a small metal paddle in a quantum superposition. So the idea that we can escape by postulating the macro world is separate from the quantum world doesn't work either. The macro world is built by the quantum world. Another escape route many materialists use is to hold to the many world interpretations of quantum mechanics, which basically argues there is no collapse of the wave function upon measurement, but that every possibility splits off into different worlds. So every quantum probability actually does play out. They just split off into different worlds, and in each one I'm observing each different outcome. But it is riddled with problems, unlike the idealist understanding, and it is an apparent violation of Occam's razor, as entities are not to be multiplied beyond necessity. Introducing a large number of worlds that we also cannot detect is an extreme violation of this, especially since this can be explained by accepting all these possibilities just exist in a mathematical probability as a wave function, instead of as actual worlds that can never be verified or falsified. An idealist understanding can explain this just fine with much less and other aspects of reality that we dealt with in our last video. The many worlds interpretation doesn't have enough explanatory power and has to postulate so much more in order to explain the little it can. As Bernard Haas says, one tiny atom's quantum behavior replicates the entire universe and defines each alternative by all the possible consequences of that behavior. But at any moment within each human body, there are on the order of a billion times a billion times a billion atoms, each making quantum transitions. In the many worlds interpretation of quantum mechanics, every human being therefore creates a billion times a billion times a billion alternative universes every second. So this is absurd to postulate and unnecessary to do so. The last and important objection that many bring up is that this leads to solipsism, which is false. Solipsism, for our purposes in this case, would be the extreme skeptical version of idealism, which says only your mind exists and everything else is an illusion. But that doesn't have to be the case, as general forms of ontological idealism just say the appearance of the physical world is created by the activity of the mental world, not that only your mind exists. In a short article ranting about why materialists cling to false notions of an independent material reality, Richard Conn Henry and Stephen Palmquist say, "Why do people cling with such ferocity to the belief in a mind-independent reality? It is surely because if there is no such thing as reality, then ultimately, as far as we can know, mind alone exists. And if mind is not the product of real matter, but rather is the creator of the illusion of material reality, which has, in fact, despite the materialists, been known to be the case since the discovery of quantum mechanics in 1925, then a theistic view of our existence becomes the only rational alternative to solipsism." And now I'll let Miki Ukaku explain why this is the case.
Erwin Schrödinger, one of the founders of quantum mechanics, designed a thought experiment to drive home the strange rules of his theory. Let's say we put a cat and a vial of poison in a box. We add an atom of radioactive uranium and a Geiger counter. If the uranium decays, it sets off the Geiger counter, which then releases the poison and silently kills the cat. Before we open the box and look, we can't actually know whether the uranium has decayed or not, since radioactive decay is a probabilistic quantum event.
Here's the question. Is the cat dead or alive? Well, according to quantum mechanics, the cat is neither dead nor alive, but the sum of the two states. Well, at that point, you say, well, that's nonsense. That's preposterous. How can you be both dead and alive simultaneously?
Schrödinger's cat was supposed to show that nothing in this universe is certain until someone makes a measurement. But another pioneer of quantum mechanics, Eugene Wigner, believed it could teach us something else about the working of the universe, that consciousness controls everything.
Wigner said, let's take it one step farther. If I, a human being, looks at the cat, I am conscious. Therefore, consciousness determines existence. At that point, Einstein went ballistic and said, what? You're saying that the fact that you are a conscious being determines the fact that the cat is alive? The answer is yes. And Wigner made one more step. And that is, how do I know I'm alive? You see, the cat and me, we're part of the same universe. If I don't know the cat is alive or dead, I could also be dead at the same time and not even know it. So who determines that I'm alive? Well, Wigner's friend looks at me, I look at the cat, and we exist. But then who looks at Wigner's friend? And there's an infinite chain of people looking at people, until finally you hit cosmic consciousness. Some consciousness that's ethereal, that envelops the universe, which looks at us and says, aha, the cat is alive.
I would even go as far to say that this position is more logical than the solipsist position, because in this case one can point out that our mind doesn't create reality, it only participates in it. In other words, we are not the architect, or have the ability to change the structure of the world through mental processes. Remember the scenario set up in the quantum enigma about opening the box. If we decide to look in one box and find where the atom is, we do not actually decide where it will end up. We just use our free will to participate in deciding what the outcome will be, whether a wave or a particle result. But we don't get to choose the specifics. So the evidence suggests we are just lesser minds dependent on a much larger one that is actually in control of the structure of the experience, and we are allowed to operate and be able to participate in the outcome of the idealist experience. Now, one objection to the theistic perspective is raised in the quantum enigma. If God is observing the physical world and us in it, then how come we can do experiments showing something unobserved is in a superposition? In other words, if God is looking down at everything, the strange rules of quantum mechanics should never have been verified, since they are always being observed by God. Well, this is a misunderstanding. God is not separate from us, someplace in space observing us, as space and matter are illusions of our conscious observation, as the falsification of realism shows. The existence of the physical world is created by our observation of it, and it doesn't exist other than that. So what is there for God to observe other than what we see? Consciousness is what is fundamental, and our consciousness would be dependent on a larger one. God is in a sense observing us having an experience of the physical world, and apart from our experience, there is nothing that needs to be observed, as it exists in the state of a wave function. So he is not separate from us, as our consciousness is dependent on his, and he doesn't need to see an independent experience of the physical world. So thus we can conclude no other. Given the scientific evidence that has led us this far, what other inference does this lead to? Of course, one can always refuse to go with us to the logical conclusion, but that does not refute the conclusion or change it. Science has not buried God, it has revealed him, and with it buried materialism. It remains now only in the fantasy of materialists.